Greetings, M Squared here. Today we're going to compare some properties of quadratic functions. Today we're going to look at tables, and we're also going to switch between vertex form and standard form. So remember, in vertex form, we can see right away what our A is. So we know this is upside down. We know it's vertically stretched because A is 2. We can tell by our H and K that it's been shifted to the right 4 and up 31, so our vertex is 431. Now we're going to change it to standard form. Hopefully you remember that standard form is ax squared plus bx plus c. Notice there are no parentheses. So basically what we're trying to do is get rid of the parentheses. And how we do that is we actually take this and we square it. So we're going to say negative 2, and when we square it, we times it by itself. So we're going to say negative 2 times x minus 4 times x minus 4 plus 31. And we have to use FOIL for this. A lot of people want to they think they know a shortcut. So they're going to say, oh, x minus 4, they just square each of them and think that's the answer. And here's my example for that. If I asked you what 3 plus 5 squared was, you would know, because of order of operations, that you have to add that together first. So that's 8 squared, which is 64. You would not, because this is incorrect, you would not say, oh, 3 squared is 9, 5 squared is 25, 9 plus 25 is 34, so that's 34. Not true. This is not the way to do it. So you would add them first. Well, when we come over here, we cannot do that because we can't combine an x with a negative 4. Therefore, we have to use FOIL, or we have to use distributive property to get the answer to that. So I'm going to say negative 2, and then in my parentheses, I'm going to do all of that. So x squared, that's x times x, right? Then we have a negative 4x and another negative 4x, which is negative 8x. And then a negative 4 times negative 4 is a 16. So that's how we simplify that. Next, we multiply through by the negative 2. We distribute the negative 2. So we get this, negative 2x squared, positive 16x, negative 32 plus 31. So when I'm finally done, when I have f of x equals negative 2x squared plus 16 minus x minus 1, because these two combine. So this becomes my equation in standard form. Now when you look at an equation in standard form, you can't see the vertex, but you can see the y-intercept. The y-intercept is always c. That's going to be important for your homework, that you be able to look at it in standard form and know what A is, know what it tells us, right? It's upside down, vertically stretched, and what the y-intercept is. All right, so these two, let's do this. 3 times, and remember I have to go like this, x minus 2. So I'm going to get x squared minus 4x plus 4 minus 11. But this whole thing right here has to be multiplied by 3. So I have to wait on that subtracting 11 until I'm all done with this. So I do 3x squared minus 12x plus 12 minus 11. So finally I get y or f of x. Either one of those is acceptable. I get 3x squared minus 12x plus 1, because these two combine to be that plus 1. Okay, this one's when we have a fraction out front. But we're not going to worry about that. Right? We're going to multiply this by itself. So that's x squared plus 8x plus 16 when I FOIL that out. Then I'm going to multiply everything by a half. We can't multiply x squared by a half, so this is the expression we write to show that we need to take half of it if we ever find x or are given an x. We take half of 8x. We can do that because we can take half of 8, and we can also take half of 16. And so we end up with f of x equals 1/2 x squared plus 4x minus 2. And what does this tell us when we look at an equation in standard form? We know our A is a half. That means it's vertically compressed. We know it's positive, so it opens up. And we know our y-intercept is negative 2. Those are things you want to notice with standard form. Okay, so what we want to notice next is that when we have a table of points, how can we recognize if it's quadratic or not? So I'm going to remind you of our little 1, 3, 5 formula that we did when we were graphing, right? When you're graphing a parabola, let's say the vertex is right there, to know where the next point is if A is equal to 1. That was our parent function, right? We know we went over 1 and up 1 on both sides. Then from that point we went over 1 and up 3 more. And then from that one we went over 1 and up 5 more. So that was our 1, 3, 5. So we use this rule to decide what A is in a table, because if we see that 1, 3, 5 pattern from the vertex, we know A is 1. If it was doubled, like a 2, 6, 10, we'd know it was A was 2. If it was halved, like a half, 3 halves, or 1 1/2, 5 halves, or 2 1/2, we would know it was 1/2. If it was 3, 9, and 15, we would know it was A was 3. So you need to remember that pattern. So I always want to notice, do you see how this is the same as this? It's 0, 6, 16, 0, 6, 6, 16. That means that's my vertex. So I'm going to write my vertex down. That's how I can tell. For our beginning purposes, we'll always put it in the middle for you, but it's not going to be that way forever and ever. So you just want to make sure you see that pattern show up. A is going to be equal to, we're going to look at our pattern. So how many from here to here? That's 2. The distance between -2 and 0 is 2. And then the distance between 0 and 6 is 6. And then here and here it's 10. So that's 6 and 10. So what do we see? 2, 6, 10. 1, 3, 5. That's doubled. So we know our A is 2. Is it +2 or -2? Well, if you think about it, you're 16, you're going on the left side, right? These are all going up by 1s. We do that on purpose because we don't want to trick you. So we got a 16, then a 6, then a 0, then a -2, and then it goes back up. Can you see it? Kind of like this. So we know it opens up, so it's positive. And because it opens up, we know that our vertex, our k value, that's the y-coordinate of the vertex, is going to be a minimum because it's going to be the lowest point of the whole graph. We know that if the absolute value of A is bigger than 1, that it's vertically stretched. And the y-intercept always happens when x equals 0. So if I want to find my y-intercept, I just look down on my x column, find my y, and say, find my x equals 0, and then that tells me what the y is. So the y-intercept is 0, -2. How do I write my equation? Well, I will always write it in vertex form because I have the vertex and I have A. That's all I need. So I'm going to say, the equation is y equals 2, that's my A, times x squared, didn't really need those parentheses because there was no shift left or right, minus 2. Okay, so we're going to look at my vertex. Looks like right here, my vertex. So I say what's happening. I'm going down 0.5, that's a half. And then from here to here is 1 1/2, and from here to here is 2 1/2. So that gets my half pattern, right? Half of 1 is a half, half of 3 is 3 halves, or 1 1/2. So I know A is a half. Is it positive or negative? So I kind of look at my y values because these x values are the same. So I'm at -4.5, then I go up to -2, then up to -0.5, then 0, and then I come down again. So I can see that it's upside down. So that's going to be a maximum. And my vertex is 0, 0. Is it vertically stretched or compressed? Well, when A is, the absolute value of A is between, it's negative because it was going down. I forgot to, that's the whole reason I did that. It's -1/2. If it is going upside down, then we have a maximum. And if the absolute value of A is between 0 and 1, then we know it's compressed. The y-intercept is wherever, the y value for whatever value x is 0. So when x is 0, we look over there and we see 0, 0 is our y-intercept. So our equation, this one's fairly straightforward because we didn't shift left or right, up or down. So it's just y equals -1/2 x squared. All right, last one. We notice our vertex is right here. So that's going to help us write our equation in a minute. What's the A value? Well, this distance is 2. This distance is 6, this distance is 10. So it looks like we're back to a 2. And then I see that it's at -22, then -12, then -6. It's going to be going upside down. So that means we're going to have a maximum value. And it's opening down. If A is 2, that means it's stretched. A is going to be -2 since it's opening down. What's the y-intercept? Right here, x is 0. So my y-intercept is -22. And my equation is y equals, then that value of A, and then x, and remember when we put this value in, it's the opposite of what we see there because the formula says -h. So if it says minus a -3, then we know it's a +3, squared -4. So in your homework, you're going to have to be able to match it. You're going to have to look at an equation in standard form or vertex form and be able to match it with another one in the other form, and also tables and graphs. But we've been doing graphs for a while, so hopefully that'll be easy. All right, good luck. M squared, signing